Hi, everyone, and welcome to the AWS Nordics Office Hours with me, Gunnar Grosch. I'm a developer advocate here at AWS, based in Sweden, and this is my weekly show where I bring on AWS experts to talk about a specific topic and let you, our viewers, ask any questions you might have. So start using the chat straight away. Let us know that you're listening and that you have questions for us. So this week, I'm joined by Matheus Guimaraes. He's a solutions architect based in the UK. And we're going to talk about SDK integrations with AWS Step Functions. Matheus' favorite subject, I think. Welcome to the show, Matheus.
Thank you very much, Gunnar. I wish I could pronounce your name as good as you pronounce mine. But now I heard you speaking again. Now I'm going to start committing that to memory. But thanks, Gunnar. Yes, I'm an enterprise SA solutions architect here at AWS. And yes, one of my favorite things is AWS Step Functions.
And that is the topic for today, but specifically SDK service integrations. And we're going to do it as usual by showing a bunch of different demos, examples of how this works. So,
hello. Sorry, I just want to say hello to Zach Jones Noel. You were on my show last week. Hey, Zach,
yes,
good to see you again.
Zach is one of our regulars, I'd say, at the AWS Twitch channel. So welcome, Zach.
Nice.
And yeah, do just what Zach did. Post your questions or comments in the chat throughout this hour. So, Matheus, when we get started, let's start off with what AWS Step Functions is and how we're seeing customers using it today.
All right. So we always would like to make sure everyone's on the same page. So if you know it, great. But it's always worth revisiting the concepts. And Step Functions is primarily and most of all a orchestrator. So Step Functions will actually connect with different AWS services or indeed even external services if you want to do HTTP calls, for example, and just put it all together for you. You can do it in a low-code way since we launched a tool called Workflow Studio last year. And you can also do it in code, infrastructure as code, or you can just drag and drop various services and then have built-in retry and catches and all kinds of stuff that come nicely packaged for you, so you don't have to worry about, and you can concentrate only on the integration between these services. So if I show you just very quickly, I'm going to show you here one. It's not overly complex, and I'm very conscious about Zoom, so please do shout out on the chat if the Zoom is not working for you, if you're watching mobile or whatnot, and I'll keep zooming in and out because depending on the screen, it can change. But good to hear that, Zach. Thank you for the support. Always appreciate. So if you look here, the workflow that we have is very much just a series of steps from one thing to another, to another, to another. And Step Functions will give you a few control states, as we call them. So a state is a step on your workflow. And for example, you will have here the choice state. So it's checking for something. We don't need to dive deep into what this is, but it's obviously checking if the last evaluated key is null. That's quite explicit there because I gave it that name. And then you have the path state, which gives you a chance to do input and output transformation. And then you can actually make your AWS service calls, such as here, we are doing a scan to DynamoDB. And then from then, we are taking the output and handling whatever comes from it. And then we continue cascading and doing different things, using different control flows, such as parallel state, which allows you to do multiple things at the same time, and then combine the results at the end for the next step, so on and so forth. So that's what Step Functions is, Gunnar. It's pretty exciting because, and the reason why I love it is because you can connect with so many AWS services now because of AWS Sdk Integrations, which we'll be talking about in a second. So really, the sky's the limit of what you can put together here and how you can use it.
And observation from me is that we're seeing more and more customers using Step Functions as well for more and more use cases. And I think that's awesome. AWS Step Functions is definitely one of my favorite services in AWS as well.
Yeah, definitely.
So let's move to the topic of the day then with SDK integrations. You touched upon some there already in that quick example, but let's talk about what it is and perhaps what was before.
Yes, and in fact, that is the perfect starting point. So in the good old times, well, maybe not so good, actually, better times now, what happened was when you worked with step functions, you had to wait for our step functions team to work on integration with different services before you could use it, right? So for example, let's pick Dynamo, since we're talking about Dynamo. You had to wait for the step function team to code an integration with Dynamo, release it so that you could use it there on your step function. Until they created those integrations for you, you had to use Lambda. So you could integrate with these services. There was a lot of power there already, and customers did a lot with step functions. However, you had to do it indirectly a lot of the times, depending on what you were doing. So say if you wanted to trigger from your step functions a scan to DynamoDB, you had to actually call a Lambda, and then from Lambda to the scan, consume the results and pass it back to step functions, so on and so forth. So what happened was we saw these monstrous step functions that were very clever, very cool, and very powerful, but there were loads of lambdas all over, which means that you have to create code, maintain code, debug code, and depending on your capabilities and capacity of your teams, that could potentially be a lot of work. So what happened in September 2021, so it's still pretty recent, is that we released AWS Stk Integrations. And what that means is now ASL, Amazon States Language, and Step Functions by consequence, which uses ASL as its code behind the scenes, which you can also code yourself instead of drag and drop if you prefer, now has support for making AWS Stk calls. Now, initially, this confused a few people because we got a few tweets of people confusing when we said AWS Stk integration with, for example, Bodo 3 or the Node.js SDK. No, this is an SDK for step functions, which we're going to see in a second how you can actually make use of it. But really, what you do is you make calls to AWS services inside your ASL via syntax. And what it does then is just connect to all these AWS services. And now that means you can connect to over 200 AWS services, which equates to about over 9,000 API endpoints, which is insane. I mean, the permutations and mix and match you can do, it really is just down to your creativity and the art of the possible. So optimized integrations remained. It's what we call those integrations that we created before AWS Stk Integrations came about and allowed you to conquer the world of AWS directly from your step functions. And some of those optimized integrations do have some baked-in optimizations, as the name implies. So some souped-up functionality to either make it more convenient or faster or easier to work with that integration. Others, not so much. Others may be exactly the same as you're using AWS integration today. So you just have to discover the ones that are worth perhaps using optimized integrations and the ones that it doesn't really matter. So you do whichever one you like.
So that means that there might be cases where you actually use the optimized integration instead of the SDK integration.
Yeah, and one of those that I recommend using optimized integration is Lambda, for example. There is also, for example, EMR. If you're familiar with EMR, Elastic Map and Reduce, it's our service that you can use to do big data computations. For example, very simple example, if you got loads of text on loads of text files and you need to parse all that for some reason, then you could use EMR for that. Now, the EMR optimized integration that still exists has a lot of abstractions over the EMR API. So to make things really easy for you and just adding conveniences as well as some optimizations. Whereas if you use the AWS Stk integration, like any of the AWS Stk integrations, you have to know the API you're connecting to. So you have to understand the EMR API, and you're going to make effectively a raw call to it. So you need to know the request parameters, what's mandatory, what's not. You need to know the response payload, the fields that you're getting back, the error conditions, all of that yourself. So The EMR optimized integrations helps you a lot with that. So it's quite a different experience. Whereas something like DynamoDB get item, which did exist before via optimized integrations, has no difference. Simply because there were no optimizations to be made. So the Step Functions team only worked on making that available for users because it was such a popular integration, but there was no optimization to be made. So it's just a raw call, much like you would do with AWS SDK. So there's no difference in that one. But Lambda does have a few differences, but they're minor, but very useful. And that's the one I want to showcase today so we understand a little bit more about those differences.
So let's get to it then, I think. Let's start showing a couple of examples of how you can actually use these integrations.
Amazing. Okay. So actually, before we go there, let's look at the high-level differences between optimized integrations and AWS integrations. So as I mentioned, different services like Lambda and EMR will have optimizations, and we're about to have a quick look on how what the differences are with Lambda. However, in general, there are actually quite a few differences also in the integration patterns when you use one over the other. Hello, Javier. What use cases have you seen from customers using Sdk integration? Well, quite a few. And because, as I mentioned, AWS Sdk integration opened up this Pandora's box in all the past possible ways, and with the best connotation possible. And before optimized integrations, we only have 17 of those, which are those here you can see on the screen. Whereas AWS integration has over 200. So you can imagine that customers now started going to town with this and replacing those. That's usually the first stopgap for those that already had step functions and they used all these lambdas. The first thing that we saw happen is that they started decommissioning all these lambdas. So it's a lot of code they got rid of that they don't need to maintain, all right, to just using Sdk integrations to all kinds of services. So that's definitely, I would say, in terms of generic use cases, the biggest use case with Sdk integration. As for specific use cases, of course, depending on the service you're using, you have the specific use case for what you're doing there. So as I just mentioned, EMR, that's a use case. If you want to, example, do some processing from your step function, and then have your next step depend on the job being completed, for example, then no, you could use a step function optimized integration, or then you could use Sdk integration to do something else. It's really down to the functionality. Yes.
Yeah, the other thing that I've seen is that the Sdk integration, service integration, it really lowers the bar for usage. So a lot of customers have started using step functions because previously having to, as you mentioned, own these AWS Lambda functions and the code within them was something that perhaps customers didn't want to do. But now they don't need to own those specific AWS Lambda functions, instead using the Sdk integration straight off.
Yes, and Gunnar, actually, one important point here is, hello, ciao, marvelous, ciao, bello, or bella. So yes, but one important point also to mention there is actually cost optimization. Very important. Why? Because step functions, if you're using standard workflows, it charges per state transition, right? So every time you go through another step, so going back to that step function that we're looking at before, every time I go, say, from scan next page to this choice state to the next one, this is when I'm getting charged. So it's like ping, 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 you know, ka-ching, 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 every time you go through each step. Whereas Lambda, as some of you may know, it charges based on duration, on execution, times, on memory consumed. So it's got all kinds of different cost model dimensions. And if you've got multiple of those, one, your cost management is a bit more complex. Two, most likely, of course, have to quantify. We're scientists. However, most likely, chances are that's more expensive than you just transitioning from one state to another on your step function if you can do it directly, if you can interact directly with these services. Of course, you're still paying for the interaction with these services, but you would have done so before using Lambda directly, only that you had a middleman to pay for as well, which now you don't. So there's that to think about as well. Okay, so going back here to optimize integration. So as we can see, we actually have 3 service integration patterns. And what is under the hood used for optimized integration APIs? Yes, and hello from Amsterdam. Oh no, do you know how to say hello in Dutch, Gunnar? I forgot, I used to.
No.
Okay, under the hood, yes, it's abstractions, right? So when you're using AWS optimized integrations, then we behind the scenes are, if you will, compiling those steps into perhaps expanding them into different steps behind the scenes that take care of certain things for you. So kind of like for C#.NET people like Link, for instance, if you're using Link on C#, then it's still all behind the scenes compiling to the same thing, but it's just sugar, adding some sugar syntax for you to make things easy, or just actually having API abstractions that translate to different APIs behind the scenes, depending on how extreme the optimization is. Like in EMR, it's a bit extreme, but not so much in other ones. So we have 3 integration patterns, and just to go over them, make sure we're all on the same page always. Request response is when you just make a request to the service and you get an HTTP status back, and Step Functions is happy with that. It's just going to continue on processing the workflow, right? However, we have another pattern called run a job.sync, sync being the hint, sync from synchronous. So this is when Step Function is not satisfied with just that HTTP status. It actually will wait for a job if that service actually runs jobs. So I'm picking on EMR today. I don't know why, but for example, EMR is a good example since we mentioned it earlier. So EMR, usually big data jobs, probably going to take some time to process. So EMR will initially return an HTTP status, say, yeah, I got it. I got this job. It's status 200, all good. But I'm going to go off and process it. And Step Functions on the request response pattern won't wait for it. Whereas with the sync pattern, it adds those smarts to say, OK, I know EMR is a service that processes jobs, so I'm going to wait for the job. I don't care that it got the job, the HTTP 200 there. I'm just going to wait. And then EMR will notify Step Functions to say, I'm done. So you run that job synchronous to the end and wait for that. And then we have wait for task token, wait for callback, which can sound a bit intimidating at first, but really all this means is pause, is when you want to pause your Step Function, and perhaps you have manual approval process. So you want Step Functions to just hit the pause button, and then you'll come back to it by hitting it with an API call saying, yeah, that was a success, or that was a failure, or approved or not approved. And then it will resume. If you're using standard Step Functions, then it will last up to a year, that pause. So you can pause it for up to a year. If you're using express workflows, which is the Step Function for quick things, then that's not supported, obviously, because as I mentioned, it's only meant for quick things. So it's express workflows. If I change the tab here, it's meant only for you to go, give me something, thank you. Give me something, thank you. And it doesn't support the pause or the synchronous ones, the synchronous pattern. Whereas on standard workflows, you will get a mix and match of support here, depending on the pattern and depending on what makes sense. Because for some of them, the sync pattern just doesn't make any sense. Like API gateway, it doesn't make any sense because all we do with API gateway is make a HTTP call, and we want an HTTP response, and we're done. So there's no job to run. So it just depends on what makes sense. However, if you look here at AWS Sdk Integrations, you will see that that text is missing from the middle. So the thing with the SDK integrations is that obviously request response is supported. That's for every single service, no matter the integration that you're using, because that's the basic one. However, when you're dealing with SDK integration, you have to imagine that what you're doing is, again, like I mentioned before, you're doing like a raw call to that AWS API. So you're just using code syntax to do that. In the case of Python, Boto 3, Node.js, you got AWS SDK, and now you got Step Functions SDK. So you are doing that in a programmatic way. However, it is a raw call to the API. So there is no smarts in terms of running, knowing that that service runs a job and it can wait for it. It's no different than you hitting the API, say, from Postman. So it's up to you to figure those things out. It's up to you to bake those smarts in. And that's already one big difference between optimized integration and SDK integration. So if you're working, for example, with EMR, if you're working with ECS, something else that runs the job, then, and other ones, SageMaker, Glue, especially code pipeline stuff, they're always jobs, right? Then I think it's really worth you exploring the optimized integrations, simply for the fact that you get that sync pattern, if anything else. Whereas if you don't need that, then Sdk integration supports actually both of the other ones. And this is where also, when we talk about wait for test token pattern here, although Sdk integrations will support it, it also sometimes may make sense, sometimes it may not make sense. Again, it's up to you. You make a raw call to the API. If you tell it to pause, maybe it makes sense to you, but maybe it doesn't. You need to do what is right for you. Let me see. We got a question.
So a question from Zach in the chat. When you say pause resume happens from the last state, is there a Sdk integration with step functions to pause resume as a specific state machine?
So that's a really interesting question. Yes, Step Functions knows about Step Functions. So Step Functions is an integration of Step Functions. And as you can see here on the screen, it was even before AWS Stk integration. We had an optimized integration for it, which supports everything, unsurprisingly, because Step Functions should know a lot about its own capabilities. So yeah, you will call those nested workflows. So a nested workflow, much like calling, say, a Lambda, you could call a step function, no problem. It's got an API, which is start execution. So you will call that from your step function, and it will behave like anything else. And as you can see, there is a tick against every single pattern. So yes, you could pause it. Yes, you could wait for the step function to complete as a job before continuing to the next step. And yes, you could just have the quick one where step function says, yeah, I'll run this, and go on with your step function. So yes, 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 yes to all of that. So the point really that I want to make is that when you got Sdk integration and you're using Sdk integration, you really have to take care yourself of what you're doing. And to exemplify that, I do want to show you the Lambda differences, because Lambda has only minor differences, and there are only 2 as well. So quite nice and compact, and fits here to exemplify really nicely why perhaps you could use optimized integrations versus Sdk. What do you think, Gunnar? Should we do it?
Let's do it. And let's then explain a use case where, because we've just said that now you don't need to use AWS Lambda functions in your step functions workflows. What would be a use case where you actually need to use an AWS Lambda function in this case?
Oh, wow. The world is your oyster. So Lambda is our very powerful serverless code as a service, if you want to call it that, or function as a service, fast. I don't know, so many names for things these days. But what matters is that you give it code and it runs it for you. And you choose the runtime. So we got .NET, we got Python, we got Node.js, we got Go. Or you can actually give it a container. So you can run anything really that you want in that container. Or you can actually even create your own runtime. So it's up to you. But yeah, with Lambda, you just give a code and it runs. So really the use case here is just millions. However, a pattern that Lambda is being used for a lot these days is our hashtag microservices that you may have heard of. If you haven't, then you've been living under a rock. So yeah, Lambda could be used to create very quickly some microservices. And then you can connect them via API gateway and have that URI call to the microservice. And from Lambda, you could connect to a data store, a purpose-built data store, such as Dynamo, or even RDS, Oracle, or MySQL, or SQL Server. So Lambda really is to host code, effectively create APIs, or even host websites if you want to go crazy with it. So yeah, all kinds of use cases there.
There's this old saying that you should use AWS Lambda to transform data, not transport data. And I think that's really what it's about here. Anytime you need to transform data could be a use case for AWS Lambda with AWS Step Functions.
I like that, yes.
So a question from Pabudu in the chat. What happens if a state machine is being modified while waiting for the callback?
Oh, well, yes. The execution is, if you will, a snapshot of that step function or how it was at that particular time. So if you modify, it won't affect that execution. Because the way it works, every time you start execution, it's going to go, OK, it takes a snapshot of that step function, and then it starts doing things. So it's just stored somewhere. And once that finishes, obviously, if you don't have that version, then the next execution will be run on the next version. So yeah, you will always maintain the original code.
I just want to bring up this comment as well. Wonderfully said, Gunnar. I like when the chat comments on what I say. Thank you. All right, so let's get to it.
I like that you highlighted. Somebody said, wonderfully said, Gunnar. Good. I'm glad everybody's motivated. So let's just look into the Lambda differences. And to do that, I am going to faff about with zooming here and panels. So forgive me, but I want to make sure this is good to be seen by everyone, including people on their phones. Perhaps turning horizontally, that could help me at least. But okay, so what I have here is just a little demo that will help us look at the differences between using Lambda with optimized integrations and Lambda with the SDK invoke type. And this is actually available on GitHub. Gunnar can share the link later on, or you can look on his social, my social, and you find it there. So you can deploy this and play around if you want later on. So this step function, it's actually quite straightforward. And the way it works is when we start the execution, we can pass in a parameter called type. And that type could be SDK or OI, SDK for AWS Sdk Integration, OI for optimized integration. And depending on what we pass, it would just invoke a Lambda using that pattern, okay? And if we don't specify anything, then it will just do the happy path via optimized integrations. If we specify OI, it will also go to optimized integration. But we also can specify force error. And if we do force error, it's going to call a Lambda that's very naughty, and it doesn't behave well, and it throws an error. And then we're going to see how optimized integration reacts to that and how SDK reacts to that. Do you think there's a difference? Wink, wink. Of course there is. Otherwise, I wouldn't have gone through the trouble of making this. So let's start by looking into the happy path. I like running things and seeing green. So I'm going to leave Workflow Studio, and I'm going to start execution. We're not going to care about the input right now, rubbish, because by default, it's going to execute optimized integration without any errors, happy path. So there you go. We got it green. Let's see what's happening here. So the step input was rubbish, that we don't care. And then the step output, rubbish as well, because choice state in step functions doesn't change the output. It's just making decisions and forwarding the input. And then it evaluated that, OK, we're not making any choices here, so I'm just going to invoke the default. The default was the optimized integration invoke for Lambda, and rubbish input, but it doesn't matter because the output was this. So this is coming from our hello Lambda. So let's switch to our hello Lambda here. And as you can see, I got that hello Lambda, nice and neat response there with a smiley face, all nice and friendly. Nice Lambda returning that response and being consumed by our step function. All good. So let's see if SDK behaves exactly the same. So let's do a new execution. And as I mentioned, just because on that choice state, I'm checking for the input variable. This is how this is working. We are now going to invoke this via SDK by typing type SDK here. And hopefully, unless I've done something wrong, this should execute via SDK. Yay! So same thing. Input was, well, actually, no, this time wasn't rubbish. It was actually proper type SDK, which made our choice state evaluate as I'm going to go to this step here, which is invoking as SDK. And then when we get here, OK, fantastic. The input was SDK. It doesn't matter because the Lambda doesn't take input. And the output was, Now, I'll ask you, does this look as good as the other one? Can anybody notice any difference here? What has happened to this output? What am I looking at?
Anyone in the chat?
Anybody in the chat can put a name to this.
Yes or no question. So
yeah, 5 seconds. Let's see. 5, because our time is limited, unfortunately. 4, 3, 2. This is 2. What am I doing? Why am I counting like that? How weird. Yes, Zach, amazing. So this is what happens. When Lambda returns something, Lambda always returns JSON stringify friendly stuff, right? So whenever you return from Lambda here, as you can see, I'm actually returning a string. I'm not returning anything very complex. So it's just a string. It's actually a JSON object that has a string inside. And then when it's consumed by your client, you have to make sense of this and you have to work with it because it will stringify that JSON, that object. And then it will escape the string inside. So what we're looking at is a escaped string because it was JSON stringified by Lambda. But isn't that curious? Like, how come when we saw by the other one, it was all nice and pretty and I didn't have to worry about anything? Because this is the first difference between optimized integration and SDK integration with Lambda. So the optimized integration for Lambda will handle JSON parsing for you. So it will take care of that, and you don't have to worry about it. So when the next step consumes the output from this, then if you pass it along like this, you're going to have to know that, oh, I did an SDK integration step, and what I'm going to get back is just a JSON stringified output. So I have to unstringify this. Whereas if you do it via optimized integration, your next step can just consume it as normal as a JSON object. So that can be impactful to how you develop it. And also, if you want to work harder or work less hard to get your input-output done. Now, it may perhaps make sense to you to actually have this in this format. So actually, this could be a good thing. It's not necessarily a bad thing. But if you're doing that raw API call to Lambda invoke, you will get the same thing. If you did that raw API call via another SDK, for example, Boto 3 on Python, then actually wouldn't get that because Boto 3 has the smarts, abstractions, and all these kind of things behind the scenes that optimize this, and then will actually do what optimized integration does. So ironically, in a way, there are some AWS SDKs that actually do have these abstractions that we put in optimized integrations to make our life easier. However, the AWS SDK for Step Functions makes things raw. It's raw call, so you get exactly what you get if you're on Postman, say, make it, or curl, making that call directly to the Lambda API. Okay. So how would you handle this on step functions, actually, if I want to transform this back into JSON, but from within my step function? Does anybody know? It's a bit besides the point, but good to know, right? Especially if you're using SDK integrations. And always fun. It's always fun to discover a bit more. Does anybody know what is the way of getting a string to JSON, dropping hints in AWS Step Functions? I talked a lot, so I'm going to give 3 seconds this time. 3, 2. I'm so weird with my fingers today. I don't know why. 1. Thank you. Yes, thank you. Exactly. So the answer is intrinsic functions. So in step functions, you have intrinsic functions, which for the programmers out there is the equivalent of static methods or static class with static methods. So these are just things that are available outside of your states, and you can just make that call like like Pubudu SJ, like Zach Jones Noel put there on the chat. So you can just use those functions inside your step, and then it will transform into JSON for you. And the way you do that, if I go to Workflow Studio very quickly, although I'm cautious of time, so I'm not going to dwell on it, is on output, you have a few options to transform your output. You can see that it actually comes with one out of the box here when you drag and drop the Lambda invoke. And that is the output path. And that is just a filter. It's saying only output this object, right? So if the API response comes, say, with, 30 JSON fields, then we're only interested in the payload field. Get the content of that and pass it on to the next step, because we don't want all that other stuff. It's noise. So that's what output path is doing. However, you also have the option to transform your output before actually passing it on to the next stage. And that is the result selector one. So if you go in result selector, you have here, for example, a ghosted out example of transformations that you could do. For example, you can go, wow, that was example. You can flatten the object by having, I don't know if you can see the ghosted out text here, status code being picked from the payload and the status code field inside payload of our response API call from Lambda. Because as we know, Lambda always returns that response format, and it has payload and then the result of the Lambda call inside. So you could do things like that. And you can also then, very quickly here, for example, let's just call this result. And what I'm doing here is saying I'm going to inject the value of the, wait, let me just type first. I'm going to get this wrong. There you go. What I'm saying here is that I'm going to get the value from my output, and I'm going to inject into this not static value. It's not like result equals 1. It's a dynamic value. This is what this dollar is doing. It's syntax, ASL syntax. And here I can go, I want the payload object inside the response to then be parsed by my intrinsic function, which, as you can see, has a funny syntax here because it's all about giving you access to things that are built into step functions outside of your state, static methods, if you will. And this way, it will convert to JSON. I'm not going to chance anything right now because I don't want demo curse, but effectively, that's how you do it. OK, so that's the first difference. That, for me alone, is one of the reasons to actually use optimized integrations for Lambda, because it does help a lot, unless you have a specific reason for the JSON stringified thing. So now let's move on and look at a second difference. And by the way, Lambda only has these two differences. Other than that, they are the same, the call to Lambda invoke specifically, right? And what we're going to do now is I'm going to put OI. Don't need it because I actually catch in the default, but doesn't matter. And this time, we're going to force error and true. And this is just because I coded this in my step functions, right? This is not like ASL code or anything. This is my step function. This is happening on the choice state, as I mentioned here. And the choice state is picking up those parameters and deciding where to go. That's all that is. And we got a red. Well, good, because I forced an error, so that's what I was expecting. And we can look at the input and see that, OK, yeah, that's what we put there. And we can look at the output. And the output is nothing. So now we look at exception. And the exception was this, error. I am a very naughty Lambda with a sad face. So at least it recognizes that it's bad. And that is effectively the output that we got from our bad hello Lambda. So let's look at a bad hello Lambda. A bad hello Lambda is indeed terrible. It only throws an error and nothing else. And by the way, because I usually do Python, because I love Python, I thought I would cater a bit for the Node.js crowd. Give us a shout if you're Node.js crowd here, because we got love for everyone. So this demo, if you deploy from my GitHub as well, is in Node.js, but it's very simple anyway. Good chance to get familiar with it if you're not. Yes, it only throws an error. So that's good, because its step functions then recognized that there was an error in the Lambda, and it blew up. It was like, OK, that step is in error, so I'm going to stop this because you haven't handled it. And the way you handle errors in step functions is by here, if you look at it visually anyway, is by explicitly telling it, if we go here on error handling tab, how to handle it. So you can go and catch errors, and then catch, for example, the Lambda error. You can have Lambda all, or you can have specific Lambda errors, whatever you want, and then choose where to go from there. So that's how you handle an error. So that's good, because that is, for me, logical behavior. We made a call to something that error, and we can catch the error in the step functions and continue our orchestration. OK, now let's have a look at SDK. And I think, since everybody here is pretty smart, you can kind of guess it's not going to behave the same. So let's understand why. Force error, not false, true. Hopefully my workflow is working. If not, I have to update the code on GitHub. And voila. So the call was successful. Yeah, we forced error, but hang on. Now the naughty one is SDK because it's green. Why is this green? Did I do something wrong? No, I didn't. It's an error. However, this is the main difference. When you use optimized integration, we baked in the fact that it understands, oh, a shell for Node.js. Yes, Zach, I just saw that. A bit late, but oh, there's a question as well. I'll get back to that question. Let me just finish my point. So the optimized integration is baked in to understand Lambda errors. So it knows that if Lambda has an error, this step should be in error. However, SDK integration, as I mentioned, it's a raw call to the API. So again, no different than if you were actually making that call, all you're getting is a response. It's up to you to interpret that response. There's nothing behind the scenes interpreting that as an error. So it will actually succeed and go, I'm good. I don't know what the problem is with this, and continue on with your step function. So you have to watch out for errors. Again, you have to work harder. You're the one who has to know the API. You have to know the inputs. You have to know the outputs. You have to know the error conditions, and you need to react to it. So you could easily react to it by having another step after and checking that the payload has an error, for example, an error type field in it. Don't forget that before doing that, you have to JSON unstringify the payload. So you are working harder here with SDK. And again,
I think that's also important then to note what you said earlier on, that you are paying for the steps, so the transitions between steps. So the more steps you actually add or need to add in this case, the more, in that case, your workflow or the invocation of that workflow will incur charges.
Exactly. So in a way, and exactly, cost optimization is always super important, right? We never want our customers to be paying more. We always want our customers to be paying less. So much so the cost optimization is actually a pillar of a well-architected framework. In case you're not familiar with that, it's just all of us architects here at AWS getting together and then putting all those best practices into pillars, so you don't need to reinvent the wheel or figure out where to start. And cost optimization is one of those, because we want to make sure that you're paying less, not more. And that could be, to your point, Gunnar, that could be one reason, for instance, why you could use the SDK here, because maybe you don't want actually to handle the error and stuff. Maybe maybe this is a log processing application, I don't know, and it just needs the input, and that's that, and you don't want to do anything clever with it, so this suffices. So SDK may have a place in your use cases. And again, let me emphasize SDK for Lambda, because every optimized integration out of the 17 available, not that many anyway, is different. This is Lambda, right? So in the case of Lambda specifically, and Lambda invoke specifically, I actually think optimized integration is the more catch-all one, where you have all these nice things that most of the time you don't have to worry about. And for most use cases, it's what you want. So this is why with Invoke, I actually advocate for optimized integration. However, that's not to say the SDK is not amazing, because past those 17 optimized integrations, then you simply have to use AWS SDK to integrate with all these other services. And that's amazing itself, because it gives you so much freedom. But with great, with great freedom and power comes great responsibility. That's all there is to it. And that's not necessarily a bad thing. So let's get a bit of the
I want to bring up this question from Javier. How can we put a back-off retry mechanism easily in this scenario when an error isn't thrown?
Yeah, so much like any other step, you do have the error handling, but you're right. Like you said, because it's not actually recognized as error, if I went on error handling, all of a sudden this is not actually going to do anything unless I force this to do something, right? So how can you do that? Well, as I mentioned before, you have to do it yourself. you have to know that you may get this and that from Lambda, and then have perhaps a state following this that reads from the output, and perhaps say a state that is it error or not error from Lambda following that, which can inspect that input, i.e. the output of the state, which becomes the input of the next one, to then determine if it is a Lambda error, or even perhaps send it into different directions, much like error handling will do for you. So in this case, it really is up to you, again, to do that. And then in that state, you could potentially then throw an error and then handle it via the step functions, catch errors, and retry strategies, or you could just do it yourself, or do retries yourself, if you will. So yes, in this case, again, I'm going to hammer the point a million times so we get this. In the Lambda invoke a SDK specific instance, you're having to work harder, including to do retry, as we just mentioned. However, there are others that's not the case, that you will get that error and it will recognize that error. And there are different scenarios for that as well. So it just depends on the API that you're using, and and what you're getting back, and how that state interprets that message. And that's actually an interesting one, Javier. I'm gonna make a note of that, because I think error handling with SDK warrants its own talk as well. So that's quite an interesting one I hadn't thought about before. So perhaps I'll put that on my step function show in some episode. We could cover that, because that's actually quite an interesting topic. But yeah, you have to work hard and do it yourself.
So let's get back to this question as well. If intrinsic functions have a library, like in the case with AppSync VTL, something like JSON parsing, string functions, map support, and so on.
So does it have a library? Depends what you mean by that. So I would say no, because the intrinsic functions themselves, as I mentioned, they're just static methods available for you within ASL, Amazon States Language, what I use to create step functions. So it's just syntax, and ASL behind the scenes will compile that into the functionality. So not so much a library that you could, for example, include in your Node.js code, or they're just really static methods. However, they do have a few of them. We have a few of them, and keep an eye out, because there is more and more coming. And we keep releasing more of them as we identify what customers are looking for, what makes their life easier. We always prioritize based on customer feedback. And for example, there is Intrinsic, that's not a bad name, for intrinsic functions that deal with strings. There is an intrinsic function for you to get an index when you're doing a map state. For those that don't know, is when you're looping through things. So there is an intrinsic function they can use for that. And there's a lot more coming. So keep an eye out for it, but not so much a library as much as just functionality you can use. Yes, thank you for the link, Gunnar. And OK, those are all the questions. Cool. So I hope you understand the Lambda differences. What I want to show you now is amazing. And again, intrinsic functions is something that is becoming more and more handy. So you'll see that on my show as well. We can perhaps actually talk about perhaps even new ones coming up. Who knows? OK, so what I want to show you now, because I'm conscious of time, is a bit of a more complex scenario than the one we just handled. And that is with S3. So the main advantage of AWS Stk Integrations, as I mentioned in the beginning, is while it has its quirks, as I just showed you, depending on the call that you're making, you actually can use it to connect to over 200 servers. So it's actually amazing. AWS Stk Integrations changed step functions forever, because people are still discovering everything they can do with it now that we made it available. And you don't have to wait for us to do that. But that also means that you connect with APIs you couldn't connect before directly from your step functions. And that means you have to know how to handle them. You have to be smart about it. It's giving you a lot of power, and you have to use that power responsibly. Spider-Man again. So what I want to show you is a call that you couldn't do before with step functions, because we never had optimized integrations that allowed you to list objects from an S3 bucket before. But now with SDK integration, you can. But then you have to watch out for something. And this is around the same theme of what I discussed on Friday on my show, that some of you were in it. And this is, you have to be careful about the data size, because the data size that you get from some of these API calls will be much larger than the data size quota that you have in step functions. So step functions can only handle up to 256 KB of data, no more. So that goes for the inputs and the outputs, as well as the API responses that it gets. Excuse me. So if step functions gets an API response that is larger than 256 KB, it will override the output. You won't get the actual output from the API. It will override it with an error saying, nope, you exceeded the data limit. So before, with optimized integrations, we never made available list types of APIs, I'm going to call them. So for example, you couldn't do a DynamoDB scan. You couldn't do a list objects v2. For those that don't know, that's the call that you make to list all the objects in an Amazon S3 bucket. You couldn't do them simply. Now you can. However, if you do it, with these list types, it's expected that you're going to get a lot of data back, even if not now, in the future, because things keep getting added to that bucket, right? So if you have that in your step function, you have to think about the possibility that eventually this needs to be scalable. Eventually, that may actually blow up if it goes over 256K. So you got to know how to do these things and how to handle these things. At the moment, because we just released AWS Stk integration, we don't really have reference architecture and patterns for all of these calls. Like I said, this is more than 9,000 API endpoint calls. So we're discovering what customers are doing slowly, and we'll be releasing material on this. And I'm working on a blog post about this. So expect these things to come in, slowly and surely. And also, we feature here on Gunnar's show, my show, and you have various sources to look up how you can handle these things. In the case of S3, here's my 2 pence. Whenever you have list types of APIs, what you want to do is the obvious thing. And I'm gonna see if anybody wants to actually contribute, although it's kind of obvious because it's on the screen, but never mind. So on a website, if you have loads of, say, products, and you're gonna display a home page, you're not gonna display all of those products at once, right? So what do? What technique can you use to display them just a bit at a time, or just some now and then give you an option to click on something and see the next bit? Anybody knows what I'm talking about? There's a clue on the screen on the states. Now, 3 seconds. 1, yes, thank you. Zach, just Noel. Very good. Pagination. So much like you will paginate your website page, you want to paginate the results coming back from this list type APIs. And then the challenge is, you're going to have to figure it out when using AWS Stk integrations, how each one of these APIs paginate, because they all do different things. S3 has different API parameters that you can use to manipulate what's coming back on the response, to keep the response small, or at least safe, to the point that you know for sure your step functions can handle. And DynamoDB scan has another way of doing it. They both will work on the same high-level abstracted pattern of, I have to manage too much data. Here's a first set, and here's a token that you can use to call me back with that token, and then I'll resume operation, send you the next page of data, right? However, each one of them do it differently. So that token, as I called it, in DynamoDB scan is called last evaluated key. In S3, it's called next continuation token. And then the way you pass in and the way you request another page is different as well. So
another challenge is that you have 2 minutes to finish this demo.
I know.
Let's see how it goes.
No. Yeah, this is not, I'm not even going to demo it. That's why it's all nice and green, succeeded, beautiful on the screen. All I want to say is, if you look at my workflow here, is what I've done is baked in pagination pattern into my workflow to make sure that that list objects call will not blow up if I got too many objects coming back. If I naively only use list objects via AWS Stk integration and didn't do anything else, then I will run the risk, as in this case it would have done, to just blow up my step function because I didn't account for that. And even if it goes green now, as I mentioned, later in the future, that will be too much data, and all of a sudden it will break, and I wouldn't understand why. And don't forget, this could be one state amongst hundreds if you got a big workflow. So it can be quite hard, for you to understand these things once things get big. So pagination, if you're using a list type API, and always look for data size differences between AWS Stk integration APIs that you're using and what step functions can handle. Keep an eye on it. And
so final question on that, I think, is, say thousands of objects come up and you paginate 10 times, would step functions handle that amount of data?
Step functions wouldn't, but you would via step functions, and that's the trick. So it won't do that for you. It is truly an orchestrator of the things that you want to do. And in this case, like I said, AWS integration is super powerful, but it leaves up to you to decide how to handle. So it can do, and my pattern here certainly does, but you have to do it yourself. And if you want to know more about this pattern, a little bit of a plug, but it's a contextual plug here. That's the topic of this Friday episode on my Step Functions show on Friday, 1 p.m. GMT. So if you're curious about this, then just join me on Friday and I'll deep dive into this.
And that is then 1 hour time difference from the rest of us. No, but you said 1 p.m.
Yes, 1 p.m. GMT.
So that's 2 p.m. CET then, if you want to know more about pagination in AWS Step Functions. And with that, Matheus, we've reached top of the hour. So tell us just briefly what we covered.
Okay, so today, hopefully you all learned what AWS Stk integration is. And the syntax is here on the screen, by the way. I forgot to actually show. This is how you make a call to AWS Stk integration. You just put AWS Stk, then the service, and then the API endpoint they're calling. That easy. So hopefully you learn what it is. You learn the difference between optimized integration and SDK. You learn that one necessarily doesn't cancel out the other. They just do different things at times. However, there are only 17 optimized integrations. Some of them are worth doing. Some of them are not so much. And Sdk integration is there for you to connect over 200 AWS services. So I hope that is that's all we have time for. But I hope that's all very clear and you learned something new today.
That's great. Thank you very much, Matheus, for joining us today. Thanks, everyone, for watching. Do follow both Matheus and me on Twitter for more cool AWS stuff, of course. And with that, thank you very much. Bye-bye.
Tak.